are starting the new lesson. You can see by your bell work, we have some new scientific terminology. So, and on our word log, you can see the same terminology. It's good?
Now it is.
All right, guys. So your bell work this morning is, what do you think elastic energy is? So before the holidays, we had learned about gravitational energy and how it works with kinetic energy. Who can explain that to me? Who can tell me how gravitational energy and kinetic energy work together?
Kinetic energy pulls things down, and gravitational energy is to gravity pull things, something like that. No.
Okay, good job. You're definitely on the right track. Think about the roller coaster that we discussed before the holidays. So when the roller coaster is being pulled up on its chain, it is gaining, say louder, gravitational energy. Once it gets to the very top, what happens? All right, beautiful. Now, Jake, gravitational energy, as soon as it gets to the very top, gravitational energy converts to what? Kinetic energy, and it goes down. When that kinetic energy builds up, what does the kinetic energy do for it?
Pulls it back to the bottom, so the gravitational energy and the gravitational force. I don't know.
It's a good try. It definitely gives it speed, Hayden. Anybody else? So think of when our conversions take place from gravitational to kinetic. When you're going up, you're gaining gravitational energy. You get to the top, your gravitational energy is used. Once you get to the bottom, your kinetic energy converges, and then what happens? The kinetic energy does what? Well, what does it do before that? All right, so your roller coaster. So your roller coaster is going up the hill. It reaches the very peak. Gravitational energy kicks in, okay, and pushes it down. When it gets down to the lowest slope, your conversion to kinetic takes place. And what does the kinetic energy do?
Pull it back up.
Pushes it back up. Beautiful, Kayla. Very nice. All right, so now we're going to look at a new form of energy called elastic energy. Knowing the word elastic, what do you think elastic energy means? Okay, rubber. Something stretchy, energy produced by rubber. Anybody else? All right, so I just happen to have a rubber band. When I pull the rubber band, okay, and I let it go, I'm pulling it back. This is an example of elastic energy, and I can make it fly across the room, right? Okay, that's elastic energy. Good job, guys. All right, so today, this is our goal. We're going to learn about elastic energy and how the energy is used. So if you look up here, Jamila, get the lights, baby. Just turn off the front light. Thank you. Eyes up here, guys. And you're seeing in this video exactly what I just showed you. That is an example of elastic energy. Okay? All right. Can anybody think of any other examples of elastic energy? A rubber ball. I love that you said that because I just happened to have an example of a rubber ball bouncing. Now look at the numbers. So let me ask you this, guys. When the ball is dropped, what type of energy is being used? Say it louder. Gravitational energy. When it hits the ground and it bounces back up, kinetic energy. But there's something else happening here, and that's what we're going to talk about today. Because if you look at this little video, notice the numbers. Watch what it does. 1, 2, 3, 4, 5, 6, and then 7. Pay attention to those numbers. And what do you notice about that ball? What's happening? What's taking place? It gets slower. Why? Why does it eventually stop? There's not enough gravitational energy, or there's not enough kinetic energy. And what we're going to talk about today, which is elastic energy. So our objective for this lesson, is I can use data from investigations as evidence to explain how various factors influence the amount of elastic energy an object has. So that's what we're going to talk about today. Okay? And there's one other video I want to show you, and it's what Janiyah was just talking about. So this is very familiar. It's a basketball in slow motion. Okay? You can see how, and I'm going to show it one more time because it's quick. Eyes on the board. You can see how the ball, when it hits the ground, look what happens. See how it almost goes a little bit flat? Okay? And so that's where the elastic energy comes in. All right, so thinking about that video, I want you to open to page, I believe it is, it's right before 37, that's where the lesson starts.
Hey, you got on the wrong page. It's page 31.
31. Okay, look on page 31. It says, we will use energy conversion diagrams as models to represent and explain what happens when a ball bounces. It says, using a diagram of a bouncing ball that your teacher made, complete the following pie charts that represent the energy the ball has at different points. Remember to add a key to your pie charts. So I'm going to go ahead and give you the pie charts because I want you, as in your groups, to discuss them. So right now in your groups, I want you to copy these pie charts and talk about what you think, I can make it bigger, what you think these pie charts are showing. That's it. Stop the song. All right. Work in your groups. Talk about them. Come on, books open. Your book what? Okay. Nice, good job, good job. Beautiful girls.
the matter with your book?
Oh, good.
What happened to your book?
It's almost done. I am losing. Come on, it just got home.
We don't do that.
I wasn't talking to her.